Hello students, in the last lecture we started with the chapter metals and non-metals. So in the previous lecture we started with the study of metals, studied about the physical properties of metals. And in this lecture we will focus our attention on the chemical properties of metals. So let us study about the chemical properties of metals now. So in this lecture we will study the chemical properties . Chemical properties of metals. So students, in this lecture we will study the chemical properties of the metals. Students, the reason behind the chemical properties of the metals is that they have a tendency to easily lose one or more electrons from their valence shell. So when they lose electrons, they form positively charged ions. So from the metal atom we get positively charged ions. Therefore metals are also known as electropositive elements. So the reason behind the chemical properties of the metals is their electropositive nature. So what is the reason? The reason is their electropositive nature. So the metals are also known as electropositive elements. Why these are known as electropositive elements? Because they easily lose their valence electrons to form positively charged ions. Therefore, they are known as electropositive elements. Now students, let us see what actually happens. Suppose this is a metal atom. This is a metal atom. And metal atom has a tendency to easily lose the electron. So when it loses the electron, we get positively charged ion plus n number of electrons are lost. So this is a positively charged ion. Positive ion. And students, you know, positively charged ions also known as cations. So here you can clearly see that metal atom has a tendency to easily lose the electron to form positively charged ion. Therefore, they are known as electropositive elements. Moreover, these are also act as reducing agents. Metals are very good reducing agents. How? So they also act as reducing agents. Students, the reducing agent property of metals is because of their electron releasing tendency. They can easily release the electrons. So this is because of electron releasing tendency. As students, what is reduction? Reduction is the gain of electrons, whereas oxidation is the loss of electrons. And what are reducing agents? Reducing agents are the substances which reduces others and oxidizes itself. So oxidizing itself means the loss of electrons. Therefore, these also act as reducing agents. Now students, I hope the reason behind the chemical properties of metals is clear to you, as these are highly electropositive elements. So this property actually is very responsible behind their formation of compounds with other elements. So first chemical property now which we are going to study is the reaction with oxygen. So first chemical property we will study here, reaction with oxygen. Students, the rate with which different metals combine with oxygen is different. Metals combine with oxygen to give you oxides, which are known as metal oxides. So what is the general equation for the reaction of metals with oxygen? We have a metal, and when this metal reacts with oxygen present in the air, or we can say when it reacts with the air, so it gives you metal oxide. And the rate at which different metals react with oxygen is different. So this becomes the general equation for the reaction of metals with metal oxides. Students, there are two characteristics of this metal oxide. Let us see what are the two characteristics. Characteristics of metal oxides. First is about their solubility. Students, generally these metal oxides are not soluble in water, but the metal oxides of the elements such as potassium, sodium, calcium are soluble. So the oxides of the metals like potassium, sodium, calcium, these are soluble in water. These are soluble in water. Second characteristic about the metal oxides is their nature. So whether the nature of the metal oxide is basic or amphoteric. Metal oxides possess two types of nature. They are mostly basic oxides, but they may be amphoteric oxides. So the nature of oxides. Nature of oxides can be basic or it can be amphoteric. I hope students it is clear. Now first of all, let us see the reaction of different metals with the oxygen. So to start with, we will study first of all the reaction of sodium with oxygen. So first of all, reaction of sodium with oxygen. Students, the highly reactive metals such as potassium, sodium, these react with oxygen at the room temperature. So they react with oxygen at the room temperature itself. Students, in the previous lecture we studied about the reactivity series and the reaction of different metals with the different chemicals like oxygen, water is based on their position in the reactivity series. I hope you remember that sodium and potassium, these metals possess the higher position in the activity series. So these are highly reactive and they react with oxygen at the room temperature. So what is the reaction? So the reaction is when sodium reacts with oxygen present in the air, we get a metal oxide which is sodium oxide with formula Na2O. So students, this is sodium oxide. This is sodium oxide. Now on balancing this equation, we will add 2 coefficient before sodium oxide and 4 coefficient before sodium, and you can clearly see that the equation is balanced. 4 sodium atoms, here you can see 4 sodium atoms, 2 oxygen atoms and 2 oxygen atoms. Now students, what is the nature of the sodium oxide? Sodium oxide is highly soluble in water. So when it dissolves in water, this is soluble in water, so it will dissolve in water to give you sodium hydroxide. And students, sodium hydroxide is a base, well-known base, or we can also call it as a soluble base, and the soluble base, I hope you remember, is known as alkali. So students, when sodium oxide reacts with water, we get sodium hydroxide. And students, on balancing this equation, we need to add 2 coefficient before sodium hydroxide. 2 for sodium here, 2 sodium this side also. 2 hydrogen atoms this side, 2 hydrogen atoms this side, and 2 oxygen this side, 1 plus 2 oxygens on the left hand side also. Now students, this sodium oxide is soluble in water, and moreover the nature of sodium oxide is basic because it dissolves in water to give you a base sodium hydroxide. Now students, next reaction is the reaction of magnesium with oxygen. Second we are going to study is reaction of magnesium with oxygen. Magnesium has a lower position in the activity series as compared to potassium and sodium. So students, the reaction of magnesium with oxygen is not at the room temperature. This reaction occurs only upon heating. So not at the room temperature. This reaction occurs only upon heating. So In this reaction, for magnesium to react with oxygen, we need to heat it. Equation for the reaction becomes magnesium reacts with oxygen to give magnesium oxide. So students, this is magnesium oxide. Let us balance this equation. I need to add 2 coefficient before magnesium oxide and 2 coefficient before magnesium. Now, what is the nature of magnesium oxide? First of all, students, when this reaction occurs upon heating. And upon heating, a bright magnesium oxide is formed with the dazzling white light. So magnesium oxide is produced with the dazzling white light. Now, what is the nature of the magnesium oxide? Magnesium oxide is basic in nature. Why it is basic in nature? We can show the basic nature of any substance by dissolving in water. If it dissolves in water to give you a base, it is basic in nature. And if it reacts with acid to give you salt and water, then also it is basic in nature. And this magnesium oxide, when reacts with acid, let us see, it is basic in nature. So we have to prove the basic nature of magnesium oxide. Here it is basic in nature. Basic in nature, how we will prove? Because magnesium oxide reacts with the acid. Let us take sulfuric acid. It reacts with the acid to give you salt and water. So the salt produced is magnesium sulfate along with water. So I hope students it is clear to you that magnesium oxide, here it is proving that it is basic in nature because it is reacting with the acid, which is sulfuric acid, to give you salt and water. So I hope students this reaction is clear to you. Next we will study the reaction of copper with oxygen. Now let us study the reaction of copper with oxygen. Reaction of copper with oxygen. Copper is a less reactive metal. So it reacts only with oxygen on prolonged heating. As you know students, copper acquires a lower position in the reactivity series, so it is a less reactive metal. Therefore, it reacts with oxygen only on prolonged heating. So, the reaction occurs on prolonged heating. And on prolonged heating of copper in the presence of oxygen, we get a black mass of copper oxide. So, what is the reaction? The reaction is copper reacts with oxygen to give us a black colored mass of copper oxide. So students, on balancing the equation, I need to add 2 coefficient before copper oxide and 2 coefficient before copper also. So this is copper oxide which is formed. And students, this copper oxide formed is black in color. Black mass of copper oxide is obtained on prolonged heating of copper in the presence of oxygen. Further students, we write this copper oxide as copper 2 oxide. What is the meaning of this copper 2 oxide? This shows that copper in this copper oxide is in 2 oxidation state. And students, it is better known as cupric oxide. Copper 2 oxide is also known as cupric oxide. Students, for the elements which exist in more than one oxidation state, for them different suffixes are used. For the one with lower oxidation state, the suffix used is -us, and for the higher oxidation state, the suffix used is -ig. Copper exists in 2 oxidation states. One is in 1 oxidation state and in 2 oxidation state. So the lower oxidation state in this case is 1. And when the copper is copper 1 oxide, it is also known as cuprous oxide. And when the copper is copper 2 oxide, it is also known as cupric oxide. And clearly you can see here that in this copper oxide, copper is in 2 oxidation states, so it is also known as cupric oxide, and this cupric oxide formed is a black mass. Now what is the nature of this metal oxide? The nature of copper oxide is basic in nature because it reacts with acid to give us salt and water. So what is the reaction? The copper oxide is basic in nature because it reacts with acid. Let us take sulfuric acid. So it reacts with sulfuric acid to give us copper sulfate plus water. So students, this is the reaction with the acid. Now when this is reacting with acid, we are getting salt and water. So this therefore shows us that this copper oxide is basic in nature because it is acting as a base here, because base reacts with acid to give us salt and water. So I hope students the reaction of copper with oxygen is clear to you. Next is the reaction of noble metals which are present very low in the reactivity series, at the bottom of the reactivity series. So those are like gold and platinum. So students, next is reaction of gold and platinum with oxygen. Students, these metals which are present at the bottom of reactivity series, they do not react with oxygen even at very high temperatures. So they do not react with oxygen. Do not react with oxygen even at high temperatures. Therefore, students, these metals are also known as noble metals. They do not react with oxygen even at the very high temperatures. Now students, I hope this is also clear to you. Next is that some metals do not react with oxygen at the rate which is expected from their position in the reactivity series. Such metals are like aluminium, iron, zinc. So let us study the reaction of aluminium with oxygen. So next is the reaction of aluminium with oxygen. Students, aluminium is not as reactive with oxygen as is expected from its position in the reactivity series. Students, this is because aluminium reacts with the oxygen present in the air to form a thin layer of aluminium oxide on the aluminium articles. And this formation of aluminium oxide on the aluminium article prevents the further reaction of aluminium with the oxygen. Therefore, aluminium is not as reactive with oxygen as is expected from its position in the reactivity series. Because it is just present below the magnesium in the reactivity series, it is not a very less reactive metal, but its reaction with oxygen is not as reactive as is expected from its position in the reactivity series. How it reacts with oxygen? Its reaction with oxygen. Aluminium reacts with oxygen to give us aluminium oxide with formula Al2O3. Now students, on balancing the equation, 4 coefficient before aluminium, 3 before oxygen and 2 before aluminium oxide. And students, you can clearly see here that this equation is balanced now. So this is the equation of aluminium with oxygen to give us aluminium oxide. Now students, what is the nature of aluminium oxide? This is aluminium oxide. What is the nature of aluminium oxide? Students, aluminium oxide is amphoteric in nature. So it is amphoteric in nature. What are amphoteric substances? Students, amphoteric substances are the ones which have both acidic as well as basic property. They can react both with acid as well as base to give us salt and water. So aluminium oxide is not basic oxide as is expected from the general metal oxides. It is amphoteric in nature. That means it reacts with both acids as well as bases to give us salt and water. First of all, what is its reaction with the acid? So let us see its reaction with acid to prove that it is amphoteric in nature. Aluminium oxide reacts with acid. We have taken hydrochloric acid to give us aluminium chloride, which is a salt, along with the formation of water. Now students, here in this case aluminium oxide is reacting as a base here, or it is showing basic nature because it is reacting with acid to give us salt and water. Now students, on balancing this equation, 6 coefficient will come before hydrochloric acid, 2 before aluminium chloride and 3 before water. I hope students this reaction is clear to you. Next is the reaction of aluminium oxide with base to show that it contains acidic nature also. So what is the reaction? Aluminium oxide reacts with base to give us a salt, which is sodium aluminate plus water is formed. Now students, in this case aluminium oxide is acting as acid, or it is showing its acidic nature because it is reacting with base to give us salt and water. Now students, on balancing the equation, 2 coefficient will come before sodium hydroxide, 2 before sodium aluminate, and students 3 before water. I hope students this reaction is clear to you. These 2 reactions show us that aluminium oxide is amphoteric in nature. Now students, one terminology or one process is known as anodizing, which is related to aluminium. What is that? So let us study what is anodizing. Students, anodizing is a process in which a thick layer of aluminium oxide is formed on the aluminium articles. So what is anodizing? Anodizing, it is a process. It is a process of coating aluminium articles with a thick layer of aluminium oxide. So students, this anodizing is actually a process of coating the aluminium articles with thick layer of aluminium oxide. Students, to get a thick layer of aluminium oxide, this anodizing process is done in the electrolytic tanks in which the electrolysis occurs. So students, in the electrolytic tank, in the whole setup, aluminium article which has to be coated with the thick layer of aluminium oxide is made anode. Therefore, this process is also known as anodizing. And the solution which is taken in the electrolytic tank, that is dilute sulfuric acid. And in this reaction, in the process of electrolysis, oxygen gas which is liberated at the anode, it reacts with the aluminium article which is made anode to form a thick layer of aluminium oxide on the aluminium articles. And what is the use of this anodizing process? This anodizing process prevents the corrosion of the aluminium articles. Now students, general question related to this topic is asked that aluminium is a highly reactive metal. Yes, it is a highly reactive metal, but still it is used in the formation of utensils. Yes, the reason is that aluminium is quite cheap and strong metal. Moreover, it is a good conductor of electricity, and when these aluminium articles come in contact with the oxygen present in the air, it forms a thin layer of aluminium oxide on the aluminium articles. And this thin layer of aluminium oxide formed on the aluminium articles prevent the further exposure of the aluminium article with the moist air and further prevents its corrosion. I hope students this reaction of aluminium is clear to you. It forms amphoteric oxide. To show that it is an amphoteric oxide, we react with acid as well as base, it gives us salt and water. Moreover, we have studied the process which is anodizing. One more metal which forms amphoteric oxide is zinc. Zinc reacts with oxygen to give us zinc oxide, and the nature of zinc oxide is also amphoteric in nature. So mostly the questions which are asked that name any two metals which form amphoteric oxides, and answer should be aluminium and zinc. Aluminium reacts with oxygen to give us aluminium oxide which is amphoteric in nature. Zinc reacts with oxygen to give us zinc oxide which is amphoteric in nature. I hope students the reaction of metals with oxygen is clear to you. Next we will study the reaction of metals with water.